What specific problem does UFO2 aim to solve in the context of desktop automation, and how does it differ from conventional RPA systems?
UFO2 aims to solve the problem of fragility and inefficiency in traditional desktop automation systems, particularly those relying on script-based robotic process automation (RPA) tools. Conventional RPA systems, such as Automation Anywhere and Microsoft Power Automate, are limited by their reliance on surface-level GUI queues, making them brittle to minor interface changes and requiring frequent manual updates. In contrast, UFO2 introduces a deeply integrated AgentOS that leverages advanced multimodal large language models (LLMs) to interpret user instructions and interact with applications through both GUI and native APIs, enhancing reliability and adaptability. This system-level integration allows UFO2 to orchestrate complex workflows across multiple applications while minimizing disruption to user activities through its picture-in-picture interface. Ultimately, UFO2 transforms desktop automation from a fragile script-based approach into a robust scalable solution that can flexibly adapt to evolving interfaces and diverse application environments.
How does the proposed method UFO2 work? Please illustrate the methodology step by step, from user instruction to execution of actions.
UFO2 operates as a multi-agent AgentOS for Windows, transforming user instructions into automated actions through a structured methodology. First, the user issues a natural language request, which is interpreted by the central control plane, the HOSTAGENT. This agent decomposes the request into semantically meaningful subtasks and identifies the appropriate application for execution. Next, the HOSTAGENT instantiates a specialized APPAGENT tailored to the selected application, which continuously observes the application state using both Windows UI automation, UIA, APIs, and visual grounding techniques. The APPAGENT then employs a hybrid execution model, utilizing either GUI interactions or native application APIs to perform the required actions, while also leveraging a speculative multi-action execution engine to predict and validate multiple actions in a single inference step. Finally, the execution occurs within a picture-in-picture PIP interface, allowing the automation to run in parallel with user activities, ensuring a seamless user experience without disruption.
Can you provide a simple illustrative example of how an APPAGENT within UFO2 processes a user command? Walk us through the key steps and actions taken.
An APPAGENT within UFO2 processes a user command through a structured sequence of steps. For instance, when a user requests to center-align a heading in a Word document, the HOSTAGENT first interprets this command and decomposes it into subtasks. It then assigns the relevant APPAGENT dedicated to Word, which initializes a React-style control loop. The APPAGENT captures the current application state using both visual input, screenshots, and semantic metadata from Windows UI Automation, UIA APIs to identify the heading text. It predicts the necessary actions, selecting the heading and clicking the center icon, using speculative multi-action execution, which allows it to generate these actions in a single LLM inference. Finally, the APPAGENT validates the actions against the current UI state and executes them, ensuring that the task is completed efficiently and accurately.
What are the key theoretical and practical advantages of using UFO2 compared to existing computer-using agents and traditional RPA tools?
UFO2 offers several key theoretical and practical advantages over existing computer-using agents, CUAs, and traditional robotic process automation, RPA tools. Theoretically, UFO2 integrates deeply with the Windows operating system, allowing it to leverage native accessibility APIs and application-specific introspection, which enhances decision accuracy and reduces reliance on fragile GUI-based interactions. Practically, UFO2 employs a hybrid GUI API action interface that combines traditional GUI actions with native API calls, significantly improving execution efficiency and robustness against UI changes, unlike traditional RPA tools that are brittle and require constant maintenance. Additionally, UFO2's speculative multi-action execution reduces latency by predicting multiple actions in a single LLM inference, which contrasts with the step-by-step execution of existing CUAs that can lead to increased overhead. The introduction of a picture-in-picture interface allows automation to occur without disrupting the user's workflow, addressing a major usability issue present in conventional CUAs. Overall, these advancements position UFO2 as a more scalable, adaptable, and user-friendly solution for desktop automation compared to its predecessors.
How is UFO2 validated or tested? Describe the experimental design, the metrics used for evaluation, and the benchmarks against which it was compared.
UFO2 was rigorously tested across more than 20 Windows applications, including Office suites, file explorers, and custom enterprise tools to assess its performance, efficiency, and robustness. The experimental design involved using two established Windows-centric automation benchmarks, Windows Agent Arena, WA, and OS World W, which consist of live automation tasks across commonly used applications, each equipped with custom verification scripts for automated correctness checking. The evaluation metrics included success rate (SR), defined as the percentage of tasks successfully completed, and average completion steps, ACS, measuring the average number of LLM-involved action inference steps required per task. UFO2 was compared against 5 state-of-the-art computer-using agents, CUAs, including Operator and OmniAgent, with results showing that UFO2 consistently outperformed these baselines, achieving a 10% higher task completion rate and a 50% relative improvement in execution efficiency. The evaluation also highlighted the effectiveness of UFO2's hybrid CUA API integration and continuous knowledge augmentation in enhancing task reliability and reducing execution overhead.
What specific results were achieved with UFO2 in terms of performance improvements over other CUAs? Include details on success rates, efficiency, and any notable findings.
UFO2 demonstrated significant performance improvements over existing computer-using agents, CUAs, achieving a 10% higher task completion rate and a 50% relative improvement compared to the best-performing CUA operator. In rigorous evaluations across over 20 Windows applications, UFO2 achieved a success rate (SR) of 27.9% on the Windows Agent Arena WA benchmark and 28.6% on the OS World W benchmark, substantially outperforming Operator's SR of 28% and 14.3% respectively. The integration of hybrid CUA API actions improved completion rates by over 8%, while speculative multi-action execution reduced inference costs by up to 51.5%, enhancing overall efficiency. Additionally, the continuous knowledge integration from external documentation and execution logs contributed to a 17.7% reduction in planning failures, showcasing UFO2's ability to adapt and improve over time. These results underscore UFO2's robust system-level integration and architectural design as key drivers of its superior performance in desktop automation tasks.